Have you ever wondered how would it feel if your bedroom's window glass suddenly breaks down after you hear the terrible sound of something like a rocket bursting up on the roof of your house? Obviously, you'll be just like an unconscious person or running out of your room because of an unseen fear. That happens very rarely that you had a chance to face such kind of situation, but you don't need to worry at all. That's not a bursting rocket on your roof, rather it's a supersonic jet that passes from your area traveling at a speed that is 5 times greater than the speed of sound. Today we'll know about the science of these supersonic jet engines, their innovative use in space rockets, and their speed parameters. So let's start. Typically, supersonic jets travel over the sea. A hypersonic flight is a flight through the atmosphere at speeds greater than Mach 5. Starting Mach 5, flights are marked by significant dissociation of air and high heat loads. For aircraft speeds that are much greater than the speed of sound, the aircraft is said to be hypersonic. Typical speeds for hypersonic aircraft are greater than 4,800 kilometers per hour. When an aircraft moves through the air molecules near the aircraft are disturbed and move around the aircraft. The air's reaction to the aircraft depends on a special formula that calculates the ratio of the speed of the aircraft to the speed of sound through the air. This speed ratio is very important. That's why scientists designated it with a special parameter called the Mach number. In 2004, NASA's launched its experimental space plane X-43A. The plane reached Mach 10, or 10 times the speed of sound, setting a new speed record. This Mach speed is equal to 10,600 kilometers per hour. It is powered by a scramjet engine. The engine is mainly fueled with hydrogen fuel. The scramjet scoops up oxygen as it travels through the atmosphere, eliminating the need for onboard oxygen. Hypersonic planes don't use a rotating compressor as a turbojet engine does. Instead, it uses forward velocity and aerodynamics to compress the air into the engine. Hydrogen fuel is then injected into the airstream. The expanding hot gases from combustion accelerate the exhaust air to create massive thrust. In hypersonic aerodynamics, the temperature of the flow is so great. At low hypersonic speeds, the molecular bonds vibrate, which changes the magnitude of the forces generated by the air on the aircraft. At high hypersonic speeds, the molecules break apart, producing an electrically charged plasma around the aircraft. Large variations in air density pressure occur. Still more curious to know more? Follow and subscribe us and let's more curious.